Topic 6 is on goodness of fit test. There are 3 subtopics. Describe the scenarios suitable to use goodness of fit test. Compute the observed and expected frequencies for a given set of data. And perform goodness of fit tests using chi-square distribution. The most important and most commonly used goodness of fit test is chi-square test, pronounced as chi-square. And this is the test that we will focus in this topic. When to use chi-square test. And what is goodness of fit? In essence, goodness of fit test is to evaluate whether the data fits an expected distribution. Wait a minute, you might have heard something like this before. Yes, normality test, which ask whether the data resembles a normal distribution. And yes, if your dataset is large enough, meaning to say that your sample size is large, we can use chi-square test. And the data is binned into categories. This means that the data must be categorical, like what is your favorite beverage in the canteen, where tea, coffee, soft drinks, Milo are the categories. There is no limit to the number of categories. So that are the common scenarios in science that we use chi-square test for. In fact, it is commonly used. For example, in food preference, whether McDonald's to Subway preference is 9-1. That is 90% of students prefer McDonald's while 10% prefers Subway. In blood group prevalence, blood bank will want to know whether Singaporean blood group falls into 40% O blood, 25% A blood, 25% B blood, 10% AB blood. In payment preference, whether 60% the population prefers electronic payment over cash. That is 40% prefers cash payment and 60% prefers electronic payment. So you can imagine, the usage for chi-square test is extensive. Before we perform chi-square test, we need to understand the difference between expected and observed frequencies and how it used to construct the null hypothesis. Expected frequencies is what you expect, which means that expected frequencies come from your research question. Observed frequencies comes from data collection. For example, if you want to evaluate whether McDonald's to Subway preference is 9-1 and you polled 150 students, then by proportion, the expected frequency for McDonald's is 135 and the expected frequency for Subway is 15. It is all right as the expected frequencies are not whole numbers, not integers but with decimals. Then the null hypothesis is the preference for McDonald's to Subway is 9-1 inch, while the alternate hypothesis is the preference for McDonald's to Subway is not 9-1 inch. Again, chi-square goodness of fit test is a non-parametric test that is used to find out how the observed value of a given phenomena is significantly different from the expected value. Observed frequencies are the actual frequencies we obtain or observe from the sample. Expected frequencies are the frequencies we obtain by calculation based on the theoretical probability concepts. The formula for chi-square statistic is given, and the chi-square statistic will be used to calculate the p-value. Back to our example. You want to evaluate whether McDonald's to Subway preference is 9-1 and you polled 150 students, then by proportion, the expected frequency for McDonald's is 135 and the expected frequency for Subway is 15. Step 1. Setting hypothesis. The null hypothesis is the preference for McDonald's to Subway is 9-1 inch, while the alternate hypothesis is the preference for McDonald's to Subway is not 9-1 inch. Step 2. Select alpha, which we use 0.05 or 5%. Step 3. Select a suitable test and we determine that chi-square test is suitable. Step 4 is to calculate the p-value. Your poll says that 125 prefers McDonald's while 25 prefers Subway. This is your observed frequency. While it is all right for expected frequencies not to be whole numbers, observed frequencies must be whole number because they are counts. In Excel, we can use the formula CHISQ test to give us the p-value. The p-value we obtain is 0.006496. Step 5. Accept or reject null hypothesis. Since p-value is 0.006496, which is lower than alpha of 0.05, we reject null hypothesis and accept alternate hypothesis. Step 6. Interpret the results. Therefore, the preference for McDonald's to Subway is not 9-1. This marks the end of our chi-square test. Before we end, I want to emphasize that we must only use frequencies or counts for chi-square test, not percentages. Let's look at two examples. In case 1, which is our example in the previous slide, we poll 150 students and the p-value is 0.006496. In case 2, I just double every value. 135 times 2 is 270. 125 times 2 is 250, and so on. But the p-value this time is 0.000119. This means that sample size affects the p-value drastically, which is why you only use frequencies or counts for chi-square test, not percentages. Please do not make this mistake. Okay, that is all for now. See you soon.